Greetings. This is the pre-lab video for the Empirical Formula Determination Lab. In this experiment, you will determine the empirical formula of a compound. You need to know a clear understanding between empirical and molecular formula in order to do so. The empirical formula is the simplest whole number ratio of the different atoms in a compound. For example, the empirical formula for water is H2O. There are various molecular formulas that are possible: H2O, H4O2, H6O3. Each of these formulas have the same ratio of hydrogen and oxygen. That ratio is H2O, which is the empirical formula. Also, the molecular formula for water is the same, H2O. This is because that scientists have shown that each water molecule can be expressed as H2O. Therefore, the empirical and molecular formula are the same for water. In other compounds, however, the empirical and molecular formula are different. For example, let's take a look at hydrogen peroxide. Hydrogen peroxide has the molecular formula of H2O2. Therefore, the empirical formula would be HO. Finally, sometimes there are two or more different compounds that have the same empirical formula. Okay. For example, let's look at C2H2. The empirical formula for that would be CH. If we look at benzene, which is C6H6, it would also have the empirical formula of CH. During this experiment, you will determine the empirical formula of magnesium oxide that is formed when magnesium reacts with oxygen. To do so, you will use the law of conservation of mass. We know how much mass of magnesium metal we start with. We will find the mass of magnesium oxide when we are completed with the lab. Therefore, we can find the mass of the oxygen using those two values. During this experiment, we're going to be using the whole clay triangle crucible ring stand setup that we have been using. Now remember that we need to wear safety goggles anytime we are heating anything in the lab. Handle the crucible only with tongs. A hot crucible and a cool crucible look identical. Do not look directly into the burning magnesium. Okay, when this metal ignites, an intense light is given off. It's almost like looking into the sun. So make sure you do not look at the magnesium when it is igniting. Do not inhale the smoke produced by the magnesium. Keep your face at an arm's length away from the crucible. Do not stir or otherwise disturb the product in the crucible. Once we are completed with the experiment, the contents of the crucible can be dumped down the sink just so we have an adequate amount of water to rinse it down. During this lab, you're going to use a setup that looks similar to this, where we have the crucible cover vented once again. Okay, you're going to take 25 centimeters of magnesium and place it in the crucible. I will show you right before we do the lab how to coil up the magnesium ribbon. So we'll take 25 centimeters, you will coil it up, put it in the crucible. Once again, do not look directly at the burning magnesium. The intense light may hurt your eyes. It's going to take a different amount of time for everyone's magnesium to reach the proper amount of heat in order to react with the oxygen in the air. I can't tell you how fast it's going to happen. Some people's happen within 5 minutes. Others may take 40 minutes. Some might not even happen. So I cannot tell you when you're going to hit the amount of activation energy necessary for this lab to occur. But you will know because you will see a bright light in the crucible. Once again, do not directly look into that bright light. After the reaction has subsided and the smoke production has ceased, okay, you need to continue to heat the crucible. Okay. When the reaction is complete, the magnesium should wholly be converted into a light gray powder. So once you think your reaction is completed, look into the crucible to make sure that you can't see any more of the magnesium ribbon. Okay. Allow for the crucible and its contents to cool, and then mask the crucible. Like I said before, when you are completed, you can discard the magnesium oxide into the sink. Just make sure you rinse it down with an adequate amount of water. When you're finished, here are the data analysis questions that you must answer. And notice for each and every one, it says to show your work. I will not accept any answers with no work. Once again, this has been the lab for the empirical formula determination. This is Mr. Braun. Chem students, let's investigate.